You guys, we're going to go over the homework from lesson 7.2.6. So we'll start with the first one here. Excuse me. What else can you prove about parallelograms? It says prove that the diagonals of a parallelogram bisect each other. For example, assume that quadrilateral WXYZ at the right is a parallelogram. Prove that WM is congruent to YM and ZM is congruent to XM. Organize your reasoning in a flowchart, then record your theorem in your theorem toolkit. So the toolkit that you've been getting from us, right? Okay, so let's see. What do we know first? We know it's a parallelogram. So what do we know about parallelograms? That the opposite sides are congruent, okay? And bottom line, what we're trying to get to, so you always kind of want to know what you're trying to hit, right? You're trying to hit that WM is congruent to YM. And then you're also trying to prove that ZM is congruent to XM. So we can't use those. We got to figure out how to get there, right? Okay, so my game plan is to use the parallel lines and show that alternate interior angles here, this and this, and then this angle and this angle are congruent, and therefore also using angle, side, angle to prove that this little triangle is congruent to this little triangle, and then by CP/CTC, those two sides are congruent to each other, and then we can prove that they bisect each other. Okay, so let's do our little flow chart here, or actually we can do a, it says flow chart. Okay, so we're doing a flow chart here. Okay, so I'm start off by saying that WXYZ is a parallelogram. You need this information first because otherwise you can't start anywhere, right? And this is given. It told us it's a parallelogram. Okay, so because it's a parallelogram, tells us a lot of things. It tells us first thing that WZ is congruent to X, Y, and Y because this is the definition of parallelogram. So definition of parallelogram. All right. Also, we know that WX is parallel to ZY. And WZ is parallel to XY. And these are also definition of parallelogram, so I didn't need to write it 2 times, okay? All right, now what's more important? Because I have these parallel lines, I can now show the alternate interior angles. So now angle Z, actually let's not go that far. Angle MWZ is congruent to angle MYX, and then angle, you can do it in two separate bubbles, but because I don't have enough space, I'm doing the same bubble since they're the same reasoning and they came from the previous parallel line, so I can put them in the same bubble here. So angle MZW is congruent to angle MXY, and that's because these are alternate interior angles, okay? And so because of that parallel line, congruent side and the 2 angles, I can now prove that triangle WMZ is congruent to triangle YMX. Oops, sorry about that. Okay, is congruent to that triangle. And the reason is because of angle, side, angle congruence, because we proved 2 angles and a side that is touching both angles. And now I can say that WM is congruent to MY and ZM is congruent to MX. Sorry, my boxes are really terrible. My ovals are really terrible today. Okay, and this leads to that because of CP/CTC, and that's how we knew that they bisect each other. Okay, all right. You can go ahead and skip the next one because we won't be sharing that with class, so that's okay. All right, next it says examine each diagram below and why it won't work, right? Why it doesn't exist. Support your reasoning, and then if a line looks straight, assume that it is. Okay, so first things first. In part A, you see that you have this side 7 congruent to 7, 5 congruent to 5, and 4 congruent to 4. So by side, these 2 triangles should be exactly the same. So that means then this 80 and this cannot be 50 because if this is 80, this also needs to be 80, right? So this cannot be 50. So side congruence, the angles must be same. And that's why it doesn't exist. Okay? All right. Similarly, I have side angle, because these are vertical angles, and side. So I have side, angle, side. So these two are congruent triangles. Now, if I were to add it up, I will see that this is 40 degrees, this is 50 degrees, that's 90. So that means that this must be 90 degrees. Well, this must be 50 degrees, right? Because of the vertical angle, and 50 plus 80 is 130. That makes this 50 degrees. So angles, again, must be the same. So that's why it doesn't exist, right? You cannot have two different angles down here that are different than the previous angle, okay? All right, what do I have here? I have a right angle here. So I have a right angle next door. I have a side that they share. So these triangles are congruent by side, angle, side again. But then these two sides are not the same. So legs, or not legs, let's just use sides. Sides must be the same. Okay, all right. Next one is an isosceles triangle. So for an isosceles triangle, the base angles has to be the same. So these two angles has to be the same. But if one's 50, one's 60, that cannot be the same. That cannot be possible. So base angles of isosceles triangles must be the same. All right. Okay. Next one, what do we have here? We have, again, same thing. We have if we look at the big triangle here, this is the big triangle, right? The big triangle has two congruent sides, so it's an isosceles triangle. So these two base angles must be the same. So same reasoning over here, so we don't have to repeat ourselves. Okay. All right. Last one here. We have, what do we have here? We have side, angle, side, right? So side, angle, side congruence, but then this is 13, this is 14, so that's not true. So the sides must be the same. Okay. All right. Again, that was too fast. Make sure you go back and re-watch it and see if you could really follow why each of these are not working. Okay. All right. Okay. The next problem you need graph paper is it's actually easier with graph paper. It says, remember, if two triangles have equal sides, it's called isosceles. We're going to decide how each of these are isosceles triangles or not. So I'm going to get a piece of graph paper here. Okay, all right, so this is 7-111. All right, there's a couple of them, right? So you have 6, 0, 0, 6, 6, 6. All right, now, yes, you can do this without graph paper, but I personally think it's a lot harder or a lot more work without a graph paper. So, you know, since we did provide you with graph paper when you picked up the materials, I think it is a lot easier to do this with graph paper. All right, so here's 5. Okay, so here are my dots, my points. 6, 0 is right here. Oops, sorry. 6, 0 is right here. 0, 6 is right here. And then 6, 6 is right here. So I connect the points. And this is why I'm saying it's a lot easier. Now when I connect the points, I can see that this is 6 units, this is 6 units, this must be 6 root 2 because we know this is a right angle here. So it's a 45, 45, 90. But most importantly, I have two congruent sides. So this is isosceles. So yes, so isosceles triangle. Okay, all right. What about B? B has the points -3, 7, -5, 2, -1, 2. Okay, so that means then I'm more on quadrant 2 here. So I'm going to make sure I have enough space. Okay, 1, 2, 3, 4. Remember my habit of always marking 5, so it's a lot easier to find my points. Okay, so first point is -3, 7. -3, 7 is right here. And -5, 2. -5, 2. Okay, go ahead and connect those two dots. And then -1, 2. Okay, now, is this isosceles? What you could do is go ahead and look at the two legs here, the two sides here, and kind of use slope triangles to help you, because we know slope triangles can lead into Pythagorean theorem, and you don't actually have to do the whole Pythagorean theorem. You can look at this leg right here and see that it has it has a squared plus b squared, so it has a slope triangle of 2 and 5. And this side here, same thing. It has a leg of 2 and 5. So we know these two are exactly the same. Since the slope triangles are the same, then the Pythagorean theorems will be the same. And so these two lengths are exactly the same. Therefore, these are equal, and this is also isosceles. Okay, again, I hope you see that it's a lot easier to do this on graph paper because you can see it better. All right, part C, you have 4, 1, 2, 3, 9, 2. Okay, so we're all in the first quadrant here again. Okay, so we want, okay, always draw out my axes. Okay, 1, 2, 3, 4, 5, 10. 1, 2, 3, 4, 5. Okay, my points are 4, 1, 2, 3. Okay, so go ahead and connect those two. And then 9, 2. 9, 2 is right here. 9, 2. All right, so you can kind of already tell that this is not isosceles because just based on the slope triangles, right? For this line right here, the slope triangles are 2 and 2. And then this slope triangle here is 1, 2, 3, 4, 5, and 1. And this slope triangle is 1, 2, 3, 4, 5, 6, 7, and 1. So none of them are the same. So not isosceles. This is a scaling triangle. All right, last one here. I have the points 1, 1, 5, negative 3, and then 1, negative 7. Okay, so that means then I have a lot more in the quadrant 4. So I want something that looks like this. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so negative 5, 5. Okay, let's mark our points. 1, 1 is right here. Oops, sorry, wrong way. 1, 1 is up here. And then 5, negative 3 down here. And then 1, negative 7 is here. Okay. Okay, so this one you have to look at it sideways a little bit and see if the slope triangles work for the two sides here. So I got 1, 2, 3, 4, 1, 2, 3, 4. Okay, so that's a slope triangle of 4 and 4. This other side has 1, 2, 3, 4, 1, 2, 3, 4. Same 4 and 4. So this one is isosceles. Okay, all right. You can use slope triangles to kind of not have to do the entire Pythagorean theorem. That's a very nice shortcut to have. Okay, all right. So then let's go on to our next problem here. For each pair of numbers, find the number that is exactly halfway between them. So the best way to do that is to take the two numbers, add them up, and divide it by 2, because you're looking for half, right? So 9 plus 15, oops, this is really taking up a lot of space. Okay, so let's do that again. So 9 plus 15 is 24, and then 24 divided by 2, you get 12. So 12 is exactly halfway between these two numbers. Okay, if you are not sure, look on the number line and you'll see this is exactly half. All right, next one, 3 plus 27 is 30. 30 divided by 2, halfway is 15. Last but not least, 10 plus 21 is 31. And then, so yes, there are cases where we're not at exactly whole numbers. So for example, this one is 15 and a half, 15.5. It's halfway. Okay. All right. We're going to practice again using these two column proofs. These are what people typically see in geometry. So this is a very good practice of this style of proof. Okay. Pen style proof below to show, we're trying to show, our end game is show that AD is parallel to EH and BF is parallel to CG, and then A equals D. Okay, wow, that's a lot of things. Okay, so if we know they're parallel, then those two are equal. Okay, unfortunately, he did not provide a reason for his proof. Copy his proof and provide justification for each statement. All right, sorry, so my mistake. Let me try again. We know these are parallel. Okay, so then you're trying to prove, your bottom line, your goal is trying to prove A is congruent to D. That's what you're trying to get to. Okay, so first thing we start with what we know. We know they are parallel, so that's given to us. Okay, so if we know they're parallel, why is A congruent to B? Well, these are alternate interior angles, and they're congruent, right? They are congruent to each other. Now, why is B congruent to C? These are corresponding angles. Corresponding angles. Okay. Now, why is A equal to C? Well, you look at your previous two statements. You have A equal to B, B equal to C. Well, if A is equal to B and B is equal to C, can I just jump and say A equals C? I got rid of what I call the middleman, right? I don't need that B to repeat itself. So when you do that, there's a couple ways to say that. This can be explained as a transitive property, right? Because you simply took out the thing they have in common. Another way is to look at this as substitution, meaning that if I know B equals C, I can replace B here with C. That's why I go A equals C. So that's another reasoning. Okay. All right. Now, look at back on my picture here. Why is C congruent to D? Well, they're opposite of each other. Remember this relationship? It's called vertical angles. And now you take a look at what you have here. You once again have that same relationship. You have A equal to C, C equals to D. So C is something they have in common. I can get rid of that and just jump from A to D. So this is once again transitive property or substitution. You don't have to write both. On a test or quiz, you can just write one of these and you'll be fine. Okay? All right, that's it for the homework.